Okay, guys, we're getting into chapter 4. So today we're going to talk about radians and degrees. Okay, we're going to talk a little bit about the unit circle. We're going to talk about what radians are, that sort of a thing. Lots and lots and lots of vocabulary that you guys need to be familiar with. I think a lot of it you are already, but when we talk about an angle, right? An angle, it says, is determined by rotating a ray about its endpoint. You're going to have some questions on WebAssign that are vocabulary sorts of things. So you can look back at your notes and see this. The starting position of a ray is called your initial side, right? Where our angle starts is called our initial side, initial meaning beginning. And where the angle rotation ends is called the terminal side, right? If something is terminated, like your job, you lose your job, right? Where the two rays come right here, form like it's called the vertex. You guys call it the point sometimes, something like that. But the initial side is where the angle starts. The angle of rotation starts because you can rotate clockwise and counterclockwise. You can have positive angles and negative ones. We'll talk about that in a second. But where you start is the initial side, and where the angle ends is called your terminal. All right, we just talked about our vertex. When you talk about an angle in standard position, okay, this is where you guys need to really pay attention. Your initial side, when you talk about angles in an initial position, when you're talking about angles on a coordinate plane, when we talk about on the unit circle, your initial side is always right here at the x-axis. That's your starting point. So when they tell you that an angle is such and such degrees or such and such radians, you're always going to start from 0. And then you're going to move in a certain direction, either positively or negatively. If I was going to have a positive angle, which way do you think I would start rotating? Upwards or downwards? Upwards, good. I think the next slide is going to talk about this. But when we talk about a positive angle, you're going to go up, to the left, however you want to say it, counterclockwise. If you have a negative angle, you're going to start at the initial side and go down. Everybody see that? Okay. Well, that's what we just talked about right there. Positive angles and negative angles. You're going to start at the x-axis, and if it's positive, you go counterclockwise, or we'd say up. And if it's negative, you go clockwise or down. But this is our initial starting spot is right here at 0. Does everybody know that this is 90 degrees up here? This is 180, and this is 270. All right, we're going to talk about degrees, but we're also going to talk about radians and what a radian is and that sort of thing. Angles can be labeled with Greek letters. You guys are going to see that a lot. This funny looking fish thing is your alpha. Beta is like a big B. We use theta a lot when we talk about trigonometry and angles and stuff like that. But we're going to talk about angles that are coterminal. All right, think about coterminal, like co-captain, co-pilot. All right, if I look at these two angles here, do you guys see how there's two angles formed by these two sides, the initial side and the terminal side? Do you see how two angles are formed? There's a positive one right here. You guys see that? But there's also a negative one, where if I go in the positive direction, I end up here, whatever the measurement is. But if I go in the negative direction, I end up there. Those are called coterminal. You can get to the same spot by going either direction. We're going to talk about how to find coterminal angles. You guys, everybody okay with that? Okay, again, we'll talk about that in a second. Now, the measure of an angle, and I have a little thing I want to show you here in a second, but a radian. Some of you guys are like, what is a radian? All right, we've always, you've heard of them, you've heard of a radian, you don't really, I think, understand what a radian is. But the type of measure that a radian is, you have a circle, right? Everybody knows what a circle looks like. You have a center, and then you have the radius. If I took this radius, if I took it, and I'll show you in a second. If I took this radius and I just moved it, like I rotated it like this, and I laid it along the outside of this circle, the distance that this covers right here on the outside is the same as the radian, or your radius. It's a proportion. And I'll show you in 1 second what I mean by that. But a radian itself is about 57 degrees. Circumference equals pi times diameter, right? You guys know that? Or what's another way I can write that? I don't know why I wrote pi divided by. It's pi times diameter, yes? Are you guys familiar with that from geometry? Yes or no? Yeah. You guys you're gonna tell me no? That's not good. If you were to find what pi was, I would divide both sides by d, right? If you guys were to do this, I used to do this with my geometry classes when I taught geometry 100,000 years ago. You can take anything that is circular, a plate, a big cookie cake, a pie, a top of a water bottle. If you measure the circumference around, like with a string, and then you measure the diameter and you divide those two, no matter the size of the circle, you'll come out with something really, really, really close to 3.14 when you divide them. That's where pi came from. So when we talk about radians, your circle is cut into 6 pieces of pi. Each radian is about 57 point something degrees. So there's one here, there's one here, there's one here, and then there's a little bit left over. So that's our 3.14. That 0.14 is a little bit left over. So your whole unit circle, your 360 degrees, is cut into 6 radians. It's by taking this radius right here, and if you just lay it on the outside of the circle, it's about 57 degrees. Okay, what I just explained to you is how our radian became into a measurement, right? So I don't know if I did a great job about that, but look, here we go. Here's a better picture maybe. Each radian, right? We take our radius, and if we just lay it right here around the circle, this is about 57 degrees. We'll say 57-ish. So each one of these is 57-ish. 57-ish, 57-ish, 57. So when you add them up, we get our 6 radians. Half of that would be 3, but it's 3 and a bit, right? That's our 3.14. And then it's 3 on the bottom and a bit. That's our other 3.14. That's our unit circle. We're so used to 360 degrees. We've now got to shift our thinking a little bit where we're going to talk about radians. Okay, when we talk about radian measurements, okay, we're going to talk a lot about radian measurements. Everything we're going to talk about from now for the rest of this chapter is going to be in radians in terms of pi. So we need to think about our coordinates, right? Our quadrants. Quadrant 1 right here between 0 and pi over 2. Think about that. What is pi over 2? What's the same as? What's up here? What is pi over 2 the same as? What kind of degrees? Pi over 2. What's up here? If I was talking in degrees, what's the up top? 90 degrees. Okay, so you need to think, you need to get in your minds, guys, that pi over 2 is 90 degrees. You have to think about where that is. When I'm coming over here, what is the degree measure that correlates with pi? 180. Good. Down here, what is the degree measure that correlates with 3 pi over 2? 270. Good. And then what is the degree measurement at 0? 0 or 360. It depends how you're looking at it. But we have to think about that. We have to be able to think in terms of radians, in terms of pi. So if I said to you, notice I wrote in blue, if I'm starting at my initial side, my blue measurements, is that a positive angle that I'm looking at or negative? Positive, right? Because I went which direction? I went up. So we need to be able to also think in negative terms. If I start here at my initial side and I go down, what is this degree measurement right here if I go downwards from the red? It's not 270, it's what? Negative what? Negative 90, good. What's over here on the left-hand side? Negative 180. What's up top? Negative 270, because we're going in the opposite direction. We're going in the negative. So you guys have got to be able to think forward and backwards. You need to know the terms acute and obtuse. What does acute mean? Smaller than 90. What does obtuse mean? Okay, good. Lots of vocab, Okay, I just talked to you guys about coterminal, right? If I have an angle, my angle measure is right here. What's another way I can get to that angle? I can go the opposite direction, right? I can come here and go all the way around, correct? Those two things are coterminal. When we talk about coterminal angles, you're going to be adding an entire circle, 2 pi. What that n stands for is, because it says that there's an infinite means there's no stopping point. There's a gajillion, trillion different kinds of coterminal angles. I can be right here at this angle measurement, right? I can go around an entire circle. And would you guys agree with me if this was, say, 30 degrees? If I went one whole circle, I'd add 360 to it. This could also be deemed as 390. Good. If I went another whole circle, I would add what to it? 360, and it would be, well, 390 plus 360? 7. What is it? 750. All right, what if I went in the other direction? What if I went negatively? I would subtract 360. Okay, so we're going to do the same thing. If you are asked for coterminal angles, you're just going to add 360 and subtract 360. But if they're giving it to you in terms of pi, I'm not going to add 360. I'm going to add what? What's one whole circle? How many radians is one whole circle? 6. So we're going to call that one whole circle is 2 pi. Half of a circle is 1 pi, right? 360 and 2 pi, same thing. So when you're asked for coterminal angles, right? Find a positive and a negative is what you'll probably be asked to do. If they are giving you an angle and it's in terms of pi, how do I know that that is in terms of pi? Because it has what in it? It has a pi symbol. Does it have a little degree measurement? No, it's in terms of pi. So if you guys are given something in terms of pi and it says find me a positive and a negative coterminal, then you add and subtract 2 pi. So in this case, if I want one positive and one negative, right? I have 13 pi over 6. Well, when I subtract 2 pi, right, we got pi over 6. Is that a positive or a negative? Positive. Just because I subtracted doesn't mean that's my negative coterminal angle. If you guys want a negative coterminal angle, what needs to be in front of your answer? A negative. So this is a positive one. How would I get a negative coterminal angle? What would I do? If this is positive, how would I figure out what the negative one was? Would I add 2 pi to it? If I added 2 pi to pi over 6, would I get a negative number? No. So what should I do to pi over 6? Subtract. You just keep adding or keep subtracting until you get a negative. So I would say, okay, pi over 6 minus 2 pi. Well, in order to add or subtract, what do we have to have? A common denominator. So nothing changes here. If I'm going to change this to 6, I multiply the bottom by 6. So then I multiply what? The top by 6. What is 2 times 6 is 12, correct? What's 1 pi minus 12 pi? Negative 11 pi over 6. If you are given an angle and it says give me one positive and one negative, you keep adding 2 pi till you get a positive number. You keep subtracting till you get a negative one. Like right here. They gave me 3 pi over 4. 3 pi over 4. If you had this on a quiz or something and I said, give me one positive, one negative. Well, if you're trying to get a negative number and you start off with a positive, should you add or subtract? Subtract. So in this case, they subtracted 2 pi, which is 2 pi over 1, right? So if I change the bottom to 4, I multiplied by 4. Then the top I multiply. So 3 minus 8 gives me negative 5 pi over 4, correct? You guys agree? Okay, so then if I take 3 pi over 4 and I want a positive one, what would I do with 2 pi? I'd add it. 2 pi over 1. Common denominator would be 4. Multiply the bottom by 4, then at the top. So what's 3 plus 8? 11 pi over 4. Are those the only two answers? No, you can just keep adding and keep subtracting. So in a case like this, there'd be no reason for you to add again to give me another one, but I'm just saying that it's not just, it's infinite. You just keep adding to find positive ones, you keep subtracting to find negative ones. Same thing. Look, I start off negative, right? So it starts off as a negative. If I want an additional negative one, I subtract. If I want a positive one, I add. You keep adding and you keep subtracting until you get one positive, one negative. All right, another way that we can look at this, guys, is degrees, which is what you are mostly familiar with. Yes? Yes? Yeah. Okay, we don't need to go over this much, I think. But when I talk about degree measurements, when we talk about degree measurements, we should be familiar with our degrees on our circle. We start here at 0. This is our initial side at 0. We move up in the positive direction. You guys see 30, 60, 90. Everybody see that? We're going to talk about right triangle trigonometry in a little bit. Not right now, but right triangle means we have a right angle. All right. Again, when we talk about, this is a lot of vocabulary, I understand that, but you guys need to remember that 360 degrees is the same as 2 pi. Half of a circle is 180. That's our pi. If you're given a problem in degrees, you answer in degrees. If you're given a problem in radians, you answer how? In radians. There you go. Okay, good. All right. To go from degrees to radians and radians to degrees, there is a conversion factor. This is super easy. This is not anything you guys need to stress about. You don't even have to memorize this because this just makes sense. Okay? Let's look at some problems. I'll show you what I mean by that. If I said to you, convert 135 degrees to radians, all right? Think about what you're given. 135 degrees over 1. Do you guys agree with me? Your conversion factor is either pi over 180 or 180 over pi, right? 180 and pi, half of a circle. If I am starting off in degrees and I want to go to radians, I need what to cancel out? I need the degrees to cancel out. So think about our conversion factors, either pi over 180 or 180 degrees over pi. Where would the 180 degrees have to go for your degree symbols to cancel out? On the bottom, right? Do you guys agree here? 180 over pi. Now you can do this a variety of ways. I'm not going to tell you guys how to do this. You can cross, cancel, and simplify. You can just multiply across and simplify, whatever. But do you notice here how the degree on top cancels out with the degree on the bottom? Yes? Now I think to myself, this is how I like to do it. What number do I know goes into both 135 and 180 just by looking at it? 5. If I divide 135 by 5, what do you get? What is it? 27. Okay. If I divide 180 by 5, what do I get? 36. Can I simplify any more?
9.
Yep, 9 goes into both. 27 divided by 9 is 3. 36 divided by 9 is what? 4. So 135 degrees is the same as 3 pi over 4. Does that make sense? All right, what about, where is it? This one. I'm starting off in
Degrees.
And I want to go to? I want to go to radians. So where is my 180 going to go and where is my pi going to go so that my degrees cancel out? Pi, good, over 180. So right away my degree signs cancel out because one's on top, one's on bottom. Right away I see I can divide by 10, right? What number goes into both 54 and 18? 2, okay. 54 divided by 2 is 27. 18 divided by 2 is what? 9. Anything else?
9. Or 9.
9. All right. 9 goes into what? 9 goes into 9 once, and 9 goes into 27 what? So 540 degrees is how many pi? There you go. Yeah, not bad, right? All right, let's go the opposite way. I don't know why I don't have any on here, but let's do that. Let's start off with negative 3 pi over 4. Does anything change now because it's negative?
No.
Nope. What does that negative sign mean?
It's going clockwise.
Perfect. It gives me the direction. If I was going to draw this angle, it'd give me the direction. Instead of starting at my initial side and going up, I would start at my initial side and go which way? Down. So sometimes, guys, if you're still having a tough time thinking in terms of radians, you can convert this to degrees, right? If I don't know, do you guys know where negative 3 pi over 4 is? I don't. I can't visualize that. So let's change this. Let's convert it to degrees. Maybe we can visualize it a little better. Where does my 180 go and where does my pi go? 180 goes on top and the pi goes on the bottom because what do I want my pi's to do? Cancel out. So right away I see, okay, good, it did. Now, can I simplify?
Yes.
Yes. What can I divide both 4 and 180 by?
4.
Okay, let's do 2. This becomes 90, right? What else? Okay, again, this becomes 1. This becomes what, 45? So what is negative 3 times 45? Negative 135 degrees. So think about this. If you were asked what quadrant that angle was in, think about this. Here is 0. Do you guys agree with me? This is negative 90, negative 180, negative 270. Where is negative 135?
Between negative 180
It's over here, right? In between negative 180 and negative 90. So what quadrant is that?
3.
Quadrant 3. If it was a positive angle, where would 135 be?
Quadrant 2.
Quadrant 2. Good. It's all about understanding the direction. Guys, that negative sign gives me direction. Good. Very good. All right. Complementary and supplementary. You guys know what those words mean. Go back to geometry. Complementary means the sum of the two positive angles is 90 degrees. Yes? Supplementary means when I add them together, I get what? 180. This is really, really, really easy to do if you have degrees. It's a little bit more difficult if we're in radians, so we need to understand how to do that. Okay, let's go here for a second. Not sure what's going on here. All right, complementary and supplementary, and then we're done for today. Complementary and supplementary means when I add the two positive angles together, I get 90 and 180, correct?
Yeah.
That means when I add the two together, and we're talking in terms of radians, we want pi over 2 and pi. So it's real easy to do, guys, when we're in degrees, because what is the complement of 72? That means I would say, okay, 90 minus 72 is how much?
18.
So 18 degrees is my complement, right? Agreed? Okay, so then I say 180 minus 72, and I get what? How much? 108. So 108 degrees is my supplement. Does that make sense? Yes or no? Okay, so let's do 148. We always start with 90 minus and 180 minus. So I say 90 minus 148. Is that going to give me a positive number?
No.
So you would say there's no complement. It's got to be positive. So what's the supplement? I say, okay, fine. 180 minus 148, which is what? 32. So 32 degrees is the supplement. What would happen if it was over 180? If the angle was 207, what's the complement? None. What's the supplement?
None.
Good. Now, it's a little harder, y'all, when we're in radians. You can convert to degrees and then do the subtraction, all that stuff. But the easier thing to do is say, okay, if I'm going to find the complement, remember, complement is 90 degrees, which is the same as pi over 2, correct? Yes? So we're going to find the complement here. I'm going to say pi over 2 minus 2 pi over 5. The 90 and the 180, the pi over 2 and the pi come first. So we need a common what? Common denominator. Common denominator between 2 and 5 is 10. So if I multiply 2 by 5, then I have to multiply the top, right? So this becomes 5 pi. Bottom here, multiply by 2. So minus 4 pi. What is the complement to 2 pi over 5? Pi over 10. Perfect. Good. So how would you find the supplement? I would do pi over 1 minus 2 pi over 5. Again, we got to get a common what? What's the common denominator between 1 and 5? 5. So if I multiply the bottom by 5, then I multiply the top by 5, correct? So this becomes 5 pi minus 2 pi. What is the supplement? 3 pi over 5. Remember, guys, if you start off in radians, you start off in terms of pi, your answer needs to be in terms of pi. It's always 90, 180 minus, or pi over 2 and pi minus. That has to come first because remember, you have to have 2 positive angles. So let's do D and then we're done. I know I've been talking a lot. So I'm going to find the supplement and the complement to 4 pi over 5. Complement. What do I start with? Pi over 2. So pi over 2 minus 4 pi over 5. Common denominator is 10. I'd have to multiply the bottom by 5, so the top by 5, I get 5 pi. Bottom by 2, top by 2. 5 pi minus 8 pi. That gives me negative 3 pi over 10. Is that my complement? No. You guys would say what? No complement or none. You get a negative answer, cross it off and tell me, oh, no. All right, one more, last one. I'm going to find the supplement. When we start with supplement, we go with pi over 1, right? So pi over 1 minus 4 pi over 5. Common denominator is 5. Great. If I multiply the bottom by 5, then I multiply the top by 5. So I have 5 pi minus 4 pi gives me pi over 5. That is my supplement. Let's talk about it for a second. Let's recap. How do you find a coterminal angle? You're adding and subtracting what? You've add and subtract one whole circle, 360. Or if it's not in degrees, we add or subtract 2 pi. Supplement means 2 angles add up to be how many degrees? 180. Complement means 2 angles add up to be 90. Remember, 90 is the same as pi over 2. 180 is the same as pi. How do you convert from degrees to radians and radians to degrees? Pi over 180 or 180 over pi. We want whatever we want to cancel out goes in the denominator. Where is the initial side of an angle? On the x-axis. Positive on the x-axis. Good. If I have a positive angle from my initial side right here on the x-axis, which way do I go if I have a positive angle? I go counterclockwise. I go up. This is positive. And if I have a negative angle, I go clockwise. Negative. Good. Remember, your plus and minus, guys, is your direction. Good job. Good job, good job, good job.